Hi, this is Saurabh Kumar Bhatt. So first of all, we start from the some fundamental forces. We have four types of fundamental forces. First one, the electromagnetic forces. These forces act between the charged particles. When the charge at rest, then the force is given by the Coulomb's law. It may be the repulsive in nature or may be the attractive in nature, but its range are infinite. Now the second one important fundamental force known as the strong nuclear forces. You know that every material just made up of small atoms. An atom consists of the nuclei. Inside the nuclei there is two fundamental particles. One is protons, another one is neutrons. And these protons and neutrons binding itself. And this binding force is known as the strong nuclear forces. As its name suggests, it is the strongest among all the fundamental forces. Even it is 100 times stronger than the electromagnetic forces. Now the third one is the weak nuclear forces. Basically, weak nuclear forces is associated with the beta decays. You will study in the higher educations. Now the fourth one, the most important fundamental force, is known as the gravitational forces. You ever think about that? Why do objects move toward the earth? Or how do objects just slow down when you put them into the motions, just like that? Who governed the motions of the moon and artificial satellite around the earth? Who governed the motions of the earth and planet around the suns? And this is all governed by the gravities known as the gravitational forces. Then what is the gravitational force? Now look here. There is one object having a mass capital n and another object having a smaller object having the mass smaller n, and separated by them is by r. Now this is explains the forces due to heavier masses. And how much this force is? This force is equal to the product of their the masses multiplied with some constant divided by the r square. And this force is attractive, always attractive in nature. And again also the heavier mass experience some forces due to the smaller ones, and its magnitude exactly same as these ones, but its directions just opposite. Now what is the value of G? G basically known as the gravitational constant, and its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. It is quite extremely small value. Because of that small value of G, the heavier object never will experience the force or move toward the smaller one objects. Now take on examples where the 1 kg body, another one having a mass of 1 kg and separated by the 1 meter. Then this object just experience a attractive force, and this force is 6.67 into 10 to the power minus 11 Newton. It's extremely small value. Now focus another ones. When let's say when the small object just place on the surface of Earth, then what happens? Then the force experienced by this object which is placed at the surface of Earth is product of the masses. That is mass of the object, mass of the Earth multiplied with the z divided by radius of the Earth. When you calculated this value, mass of the Earth multiplied with the z divided by re, then we found its value is 9.81 meter per second square. And this is known as your accession due to gravities. Now taken some example, interesting example to understood what is the effect of the gravities. There is one man standing vertically, and its height, let's say L sub v. When you just take an experiment, then you found that when an object just stand vertically, then its height or then its length slightly higher than when this object when lay down on the horizontals. When it lay down the horizontals, its length slightly lower than as compared to the object standing on the verticals. And this could be happen due to the gravity, because when you stand vertically, then all the tissues, soft tissues and ligaments just compressed by the gravities. When you just lay down on the horizontal planes, then all the soft ligaments just expanded. Now taken another interesting examples to understand what is the meaning and what is the importance of the gravities. When the NASA conduct the first space mission experiment, then all the astronauts just complaining about the suits, that is the suits are too tight. Then the NASA just conduct the experiment, and it found that any man having the 6 feet and it placed for the 2 days up in the absence of the gravity, then its height grown by the some 5 centimeters. That means the absence of the gravity is the height of the any person just grown by some centimeters. After that, the NASA rebuilt the suits and correct themselves. Why it could be happens? It could be happens because in the absence of the gravity, then all the ligaments or soft tissues just expanded and its height slightly increases. Now, what is the accession due to gravity? That is the small g. Let's say when the body has been released, then it after the velocity after or speed after the 1 second is 9.8. After 2 seconds, just its velocity become the twice, that is the 19.6. After 3 seconds, its velocity become the twice of the 9.8, that means 29.4. That means after t seconds, its velocity becomes 9.8 multiplied with the t meter per second. That means in every second, its velocity increased by 9.8 meter per second, and this is known as your acceleration due to gravities. Thank you, Vaiju, to giving the opportunity to stand here and deliver some interesting facts. Thank you.